In this whole section, you're going to be given a shape, and rather than ask to find the area of the shape, they're going to say, well, if we change a certain dimension, how is that going to affect the area of the new shape? So right here, this triangle in number 1, we're given a shape, and they're saying to you, if the height of this triangle is multiplied by 6, how is that going to affect the new shape? It's not saying what is the area of that shape, it's saying how many times bigger is it going to get. So let's just think about that for a second. The area of a triangle is base times height divided by 2. And they're saying to multiply the height, here, see this, the height, by 6. Well, let's just look at our formula right here. If we multiply this height by 6, how many times bigger is the new shape going to be? And I hope you can see that it is actually 6 times bigger. And if you're not sure about that, you can always find the area of this shape right here, and then times the height by 6 and find the area of the new shape and see how many times bigger it is. Okay, let's try this one. The diagonal of SU of a kite with vertices and then all these points is multiplied by 1/3. Well, I could sketch a graph here, sketch a drawing here, and I'll show you what that looks like. So I've been kind enough to plot those points for you. You can see this is what the kite looks like. But actually this isn't really going to be necessary in helping us answer the question, because if we write down what the area of a kite is, we've already learned that a kite is diagonal 1 times diagonal 2 divided by 2. That is the area. Now, what have they asked you to do in this question? Well, they've said to multiply the diagonal by 1/3. So that's this right here, just one of the diagonals by 1/3, which means the area of the new shape is going to be 1/3 of the old shape, or original shape, you could say, original shape. Another way you could say that is you could say it's going to be 3 times smaller, because 1/3 is the same as 3 times smaller, isn't it? This time I'm going to show you a different way to manipulate it. So if they give you a trapezoid, and we know that a trapezoid is a shape that looks something like this, not the best drawing in the world, there's the height right there. So they told you that the trapezoid has base lengths of 18 and 12, and they told you that the height is 5, so that's this one right here is 5. And they want you to multiply what by 1/3? Well, it says the height is there, and the height of 5 centimeters. So the height of this shape right here, this shape, is going to be multiplied by 1/3. So let's just write our area formula for a trapezoid, okay? It's B1 plus B2, all of that times by the height divided by 2. They've just said that they want you to multiply the height by 1/3. So the new shape is going to be bigger or smaller. Well, 1/3 should give you a clue that it's going to be smaller. And how many times smaller is it going to be? Well, it's going to be 3 times smaller. So, nice and easy. For the next few questions, I want you to consider how the area is going to be affected and how the perimeter is going to be affected. So we're now talking about a rectangle, because you can see that right there. And they tell you the rectangle is, what, 5 by 4 feet. And what's going to happen if both are doubled? See how I'm circling important words and underlining the important words? Well, if we're talking about area, isn't area of a rectangle equal to base times height? And now let's look at what they've given us. Well, they've said that both the base and the height are doubled. So we take this part and we times by 2, don't we? And we take this part and we also times by 2. Well, if we do times 2 times 2, doesn't that mean the area is going to be 4 times bigger? That's because 2 times 2 is equal to 4. Another way you could be sure of this is you could draw yourself a new rectangle, right? And you could say, well, they asked me to double that, so that side's now going to be 8. And they asked me to double that, so that side's going to be 10. So this area is going to be 80 feet squared, isn't it? And the original area was 5 times 4, which is 20 feet squared. How many times bigger is 80 than 20? Well, it's 4 times bigger. So that's another way to get to the answer, and that you may or may not like that method of trying to figure it out. Now let's consider perimeter. Okay. Well, looking at the original rectangle, let's just erase that. This side must be 5 and this side must be 5, right? Now if we double the dimensions, just like I did a second ago, this is going to be 10 and this is going to be 8. Now the original shape, what's the perimeter of that original shape going to be? That perimeter is all the way around, so it's 5 plus 4 plus 5 plus 4. Perimeter is going to be 18, isn't it? Now let's look at the new shape, where we've got 10, 8, 10 and 8. So that's going to be 20 plus 16 is 36. How many times bigger is 36 compared to 18? Well, it's 2 times bigger. So that's another way you can figure these out, is by actually drawing the new shape with the dimensions and just working it out completely. And we can do this problem again in 2 ways. The way I like to do this, I like to say, okay, the area of the original circle is pi times radius squared. And what have they asked us to do? Well, they've asked us to take the radius and multiply it by 1/5. This is the radius right here, okay? Well, for area, if we multiply that radius by 1/5, it's not going to just affect the area by 1/5, and the reason is because if you look at that, in this formula, can you see how the radius is squared? So actually, we need to take that 1/5 and we need to square it, which is going to give us 1/25. So that means the area is going to be multiplied by 1/25, or you could say it's going to be 25 times smaller. Now let's consider the circumference. Well, the formula for circumference is pi times diameter. Well, let's think about this. If the radius of the circle is doubled, how does that affect the diameter? Well, the diameter is also going to be twice as big, isn't it, if the radius is twice as big? In other words, the new circumference is going to be 2 times bigger. But in this question, we're not doubling it, are we? We're taking the radius and we're multiplying it by 1/5. So in this case, your circumference is going to be 1/5 of the original circle, or 5 times smaller. Here we go again. Let's underline important information. So the base and the height of a triangle are tripled, and that's the base and the height. So let's start by thinking about area, and I've drawn that triangle right here, although it doesn't really even need to be observed in this question, because we know that the area of a triangle is base times height divided by 2. And what have they asked you to do in this problem? They've asked you to take the base and triple it. So in this formula right here, see that b? If we're going to times that by 3, that's going to make the area 3 times bigger. But they also asked you to do the height as well, didn't they? So that is also times 3. Well, times 3 times 3, that means we're going to get 9 times bigger on the area, doesn't it? So that's that part. Now let's consider perimeter. Well, with regard to the perimeter, this one's a lot more complicated, and actually in the test you won't be asked for this one in a triangle because there isn't really a concrete answer we can give you. So let's just pretend that this question does not exist. But we can start attacking number 4, so let's just clean this up a bit. Alright, so how are we going to do this? Well, they've given you a circle, All right, there's my circle. They've said that the circumference is equal to 32 pi. Now our circumference formula is pi times diameter. So if I just erase that circumference part, we can solve this and find out what the diameter is. So we can divide by pi, and we end up with diameter equals 32. This means that radius is half that, which is 16. So we now know that we have a circle with a radius of 16. Okay, and what do they ask us to do? They ask us what happens if the area is multiplied by 4, what happens to the radius? So one way you could do this, you could say, okay, the area of this particular circle is pi times radius squared, which is pi times 16 squared. And if I put that in my calculator, I'm going to go 16 squared. So that's going to give me 256 pi. Okay, I'm leaving it in terms of pi, it's going to make it easier. Now they just said, what's going to happen to the radius if this area is 4 times bigger? So let's times 256 times 4. So 256 times 4 gives us, so our new area is 1024 pi. So how do we work backwards? Well, the formula for area is pi times radius squared. So let's divide by the pi's, and we're left with radius squared equals 1024. And let's hope that when we do the square root of 1024, that we get something nice. And we actually do. Surprise, surprise, you get radius equal to 32. Now, let's think about why we got that answer for a second. So what you should notice is the original radius was 16, and the new radius is 32, so it's actually 2 times bigger. I'd like to attempt to answer this question in a slightly simpler way, and hopefully you can understand what I'm getting at here. But earlier I made the statement that if you have a circle where the area is pi r squared, and you times the radius by, I don't know, let's say 5, how many times bigger does that make the area? I hope you can see that we have radius squared, right? So if we times the radius by 5, isn't that going to make the area 25 times bigger? Because you're putting the 5 in and you have to square that 5. Well, in this question, they're kind of working backwards. They're saying, what about if the area is multiplied by 4? How does that affect the radius? So in effect, what we're saying is we have to undo this squaring here. And what we say is, because they've given us multiplied by 4, we do actually, instead of squaring the area, we square root the area. And the square root of 4 is 2. And that's why we got this 16 in the first and 32 in the second. That's a much easier way to answer that question if you can grasp that concept.